Hi everyone, today we're going to be looking at displaying data, specifically frequency polygons, back-to-back stem and leaf plots, and pie charts. So let's have a look at the first one, frequency polygons. You might remember previously that we did bar charts and histograms. Frequency polygons also help us look at the trend of the data, and we do so by looking at the midpoints. So here we have a histogram. To do a frequency polygon, you have to look at the class intervals, and if you've forgotten what class intervals are, these are the class intervals, the sizes of each column. So we have to look at the class interval and find the middle point. So for the first one, we have 150 plus 155 divided by 2, which gives us 152.5. And we do that for each of those sections so we can find the middle point. You should get something like this. After that, you draw a point in the midsection of each bar, like so. And notice that the first dot and the last dot has an exact distance of half of the class interval. So if this is the class interval here, that size, that distance there is half of the other class interval. So this class interval here, this is half. Same with the other side. This point here is half the distance. And then all you have to do is join the lines like so. So let's have a look at this example where we surveyed students and asked them how many hours a week do you stay on social media. So here's a stem and leaf plot of the results, and we can see from the key here that 1*3 means 13 hours. First of all, we have to look at what are the class intervals. Here we have 6 to 9. So that means the class interval is 5 to less than 10. The next one is between 10 and 14. So it's 10 to less than 15. So we're going by fives. I'm just going to write it down so it's easier for us to see what I'm doing to find the midpoint of these class intervals. So the midpoint for the first class interval, 5 plus 10 divided by 2 is 7.5. 10 plus 15 divided by 2 is 12.5. So this is the horizontal axis, hours per week, and the frequency. So for the frequency, we count how many values there are. So here we have 3, 6, 7 values. We have 7 values, 5, 1, and 2. So now we can sketch the axes. So the frequencies and the hours on social media. So the midpoints are right there. So we look at the first one, 7. Next one, 7, 5, 1, and 2. So we've got our bars for our histogram. And for the frequency polygon, we put the dots in the middle, and then we join the lines. And remember to always join half a bar to the left and half a bar to the right. So these points here. Now frequency polygons are very handy when you have two class sets and you wanted to compare them. So class A and class B, for instance, you can put them overlapping each other. Let's look at another example where you have ages of teachers. So here we have female and male data, and we can do a back-to-back stem and leaf plot. And then from the data, we can do a frequency polygon as well. So have a look at this. We're going to have males on one side, females on the other. And remember, the values closest to the stem, remember this is the stem, are always going to be smaller. So smaller here and here, and as they go outwards, it's ascending or getting bigger. So you can pause here and fill in the gaps and then come back when you're done. So to fill in the numbers, we go 22, 24, 27, 29. We put that in the 20s. Then we have 31, 32, 35, 35, 37, 39. And you do continue doing that until you reach the last value. And then for the male numbers, you look at 23, 27. You go from the closest to the stem first, 23, and then 27. So let's try that again, 30, 31, 32, 36, 39. So 0, 1, 2, 6, 9 from the stem outwards. And keep the numbers aligned, so one on top of each other. Don't put these lines in. Keep them aligned so that you can have a look and quickly see how many values there are in each section. So now that we have the back-to-back stem and leaf plot, let's try and do a frequency polygon. So here we have 6 values, so we're going to expect 6 points for the horizontal axis. So we have 4, 6, 4, 4. Those are going to be how tall our bar charts are. And here is the frequency for the males. 2, 5, what else do we have here? 6, 4, and 1. 60 is a value. Oh, and 0 on this side. So let's do the axes. And I've again used the midpoint of each of the values. So here we're going by tens. So this first stem here represents 20 to less than 30. So halfway of that is 25, hence why we have 25 down here. So for the male set of data, we have 2, 5, 6, 4, and 1. We can join these with the dots in the midpoints. And there's our frequency polygon. And we can do the same for the females where we put the dots in each correct spot, 4, 6, 4, 4, 0. And then we join their lines. Be very mindful of this little tiny line here, that red section there, because it has to end halfway the distance of the last class interval. So looking at this, don't forget to put a title on it and a key. So ages of teachers for this example. And we can see that from the frequency polygon, we can quickly see that most teachers that are female tend to be younger than male teachers. And male teachers seem to be having a bigger range of age, as in that they teach for longer. Let's have a look at pie charts now. So here we have a pie chart. First of all, I want you to think what fraction of the pie chart is colored red? And how would you represent this quarter in degrees? So here we have the going all the way around would be 360 degrees. This section here we know is 90 degrees. So a quarter equals to 90 degrees. I want you to think about how do we go from 360 to 90 to a quarter? And here we have another pie. What color is it? Blue. And again, how many degrees is this? Well, if this whole thing is 360, then each section, a third of that would be 60 degrees. And how do we get 60 degrees if we had a third? So 360 times the fraction would give us how many degrees in the pie chart. Go back to the other example. So for this one, 360 degrees times a quarter would give us the 90 degree that we can see. Now this is very handy, 360 times the fraction that we want. I'll show you why in a second. So here's an example where we have to draw a pie chart. In a survey, people were asked to indicate what were their favorite pie. If you ask me, I love banoffee. The information is given in the table and we have to figure out how to draw a pie chart. First of all, we need to know what fraction each of these are. So we have to find the total. So you add them together and you realize you get 60. Now 15 out of 60, what is that? Well, the first one is easy. 50 out of 60 is equal to a quarter, which we know is 90 degrees because we do a quarter times 360 and we get 90 degrees. Well, what about 12? Well, 12 over 60, we don't have to simplify. We can directly multiply by 360 and we get our answer by simplifying now. 6 times 12 is 72 degrees. And we can continue doing this where we write the fraction over the total times 360 to figure out our numbers. And we can see that there is a pattern here. If you haven't noticed yet, let's have a look at one more. 18 over 60 times 360. You can see that all we're doing is multiplying by 6. "90, 72, 66, 108, etc. Now, how do we draw this? So first of all, you take a ruler, draw a line. It doesn't matter where you start, really. Then you need a protractor. And then you measure out. So the first angle is 90 degrees. So you put a little dot there and you will draw a line straight across. And then after that, you go for 72 degrees. 72 is over in between 70 and 80. Be very careful not to go backwards. So it's somewhere there. And then we do 66. So always realign your protractor. 108. And the last bit, if you look carefully, it should read 24. So label all your titles. Let's look at one last example. Here we have a totally non-biased survey, and students were asked to indicate which of the subjects were the favorite. Here are the results. So again, we have to find a total, so we know how much of each fraction each of our topics are, and it's 36. And then we can do two things here. We can look at 36 times what is 360, and we can kind of do a shortcut to get to all the values here. If finding a pattern scares you, what you can always do is take the value that you're looking at, for example, for maths is 12, and put it over the total, which is 36, and then multiply by our 360 degrees, which gives us 120. So it gives us the same value. So if you're ever worried, all you have to do is take the value of your data, whatever it is, divided by the total, so in our case was 36, and then timesing it by 360 degrees to give you the angle that you need to draw for that particular data. Okay, I'll leave you to it, have fun, and then you can compare your results at the end of the video. Bye.